Thank you all for coming. Welcome to this new series that we launched with the engineering workforce development of the Center for Quantum Network and the Yale Quantum Institute. We are delighted to be here. My name is Florian Karl. I'm the manager of the Yale Quantum Institute, and I will be moderating this panel with my colleague, Russell Baye. So this series, we are kickstarting this series with one event today about prepare for college, because we've realized that building quantum technology is something that requires a lot of people with different background. We need physicists, we need electrical engineer, we need computer scientists, software engineer, chemists. There's a lot of trades that we need, and it can be very overwhelming to consider a career in quantum science and information. And so by attending this session today, you will hear from college students, from staff and faculty in the field, what it's like to work in quantum, and hopefully you can get advice on navigating the various pathways that you can take. So this event will be recorded. So a little bit of technical details on the Zoom. You can only see and hear the panelists. You have a feature at the bottom of your screen that has the Q&A panel. So if you click on it, you should be able to type your questions. And then you can also put a thumbs up on the question you want to answer the most. And so the most requested question will go to the top. And then Russell and I will go through them and ask to the panelists. There's also closed captioning if you want, and this will be recorded and you can watch it later on demand. Before we start, I would like to introduce my colleague Russell Baye, and he will be the second moderator with me, and he's going to say a few words.
Thanks, Florian. So yeah, I'm Russell Baye. I'm with the Center for Quantum Networks, and specifically with the Engineering Workforce Development team. I'm the assistant director. So just real quick, a little bit about the Center for Quantum Networks. It's a National Science Foundation funded center that just got started late last year, and we are a part of 10 different institutions, or sorry, there are 10 institutions in our center, including Yale. I'm specifically with the University of Arizona, which is the lead institution. And so the Center for Quantum Networks got started because one of our big goals is to help lay the foundation for a socially responsible quantum internet, which some of you have probably heard about, hoping that this is going to spur new technology industries, competitive marketplace for quantum service providers, and application developers for the benefit of all. Like I said, I'm specifically with the engineering workforce development team. So a lot of what our goals are include trying to develop the future workforce to be a part of the quantum internet and help develop it, and also help develop the quantum network. So a lot of what we do is outreach and trying to educate people and try to get people interested in the quantum internet and technologies and all this kind of stuff that some of you are going to hear about today. So real quick, if there are any teachers out there, we are looking for some classrooms to actually run some virtual field trips where students will get to kind of have an interactive peek into some of the cool stuff that happens in these labs that are doing things related to the quantum internet and quantum networks. So I don't think Florian mentioned this, but how he got interested in quantum. But to be honest, I actually have no background in quantum. I have a PhD in geology, so a lot of this is new to me, and I'm going to be learning a lot. But for me, I think kind of one of the cool things about quantum is just how interesting it is, and just kind of the weird, crazy stuff that goes on with quantum. So thanks, Florian.
Thank you, Russell. So before we introduce the panelists, since we cannot see you, we thought that it would be fun to have a little poll happening in the chat. So you will see a poll, and then you can tell us what is your interest. Are you interested in STEM, in a career in STEM? And so we can learn a little bit more and make sure that we target or answer to your needs. So the poll should pop up on your screen right now. and then we'll start with the panelists. So maybe let's start with, so you can start turning on your webcam. Thank you all for being here. And then we can start with maybe Shantanu, if you want to introduce yourself and tell us all about what you do.
Yeah, first of all, thanks so much for having me here. I would really enjoy going to such an event if I were starting off and if I were interested. So I'm happy to be here. My name is Shantanu Jha. I recently graduated from Yale this past December. While I was there, I studied physics and math, and I started off in quantum information science by doing research with Professor Gervin, one of the other panelists here today. Later, I did research in Professor Deveray's group in quantum engineering, where I could build superconducting systems, quantum platforms onto which we realized qubits and other cool things. I also founded the Yale Undergrad Quantum Computing Org, and we can talk a bit about that later. But through that, I was able to meet a lot of cool people and make a lot of cool projects. Yeah, so really happy to be here. Hello.
Thank you. Ayelet, do you want to go next?
Yeah, I would love to. Thank you so much for having me. My name's ayelet Kalfas. I'm a rising sophomore at Yale majoring in physics, and I'm the director of partnerships at UQC, the organization that Shantanu started this past year. So it was actually a dark November night during quarantine when I received an email from YQI about the upcoming lecture that night, why you should care about quantum computers. And I had no plans for that night, so I decided it'd be a fun night activity for my family. I set up the TV in our living room and we started watching, and I hadn't really realized that quantum computers were something that existed outside of Marvel movies. And as I sat there watching, I just realized that this was an amazing, exciting, interdisciplinary field that combined a lot of my interests, and I started to see a future for myself within that field. And then a few days later, I got an email about the formation of UQC, this undergraduate quantum computing club. So I joined, and since then I've only grown more and more enthusiastic about quantum computing and my place in it. At Yale, I'm also the outreach chair for Women in Physics. I'm involved with the Student Film Festival. I'm currently co-directing a mini documentary, and I'm actually going to be doing research with Professor Gervin this summer, and I'm really looking forward to that. Thank you so much.
Well, this is the perfect transition then for Steve to go next.
Hi, I'm Steve Gervin. I'm professor of physics and professor of applied physics at Yale. I also have temporarily a half-time position at Brookhaven National Laboratory, where I'm the director of the Co-Design Center for Quantum Advantage, one of the 5 national quantum information science research centers recently funded by the Department of Energy. I'm the faculty advisor to the club that Shantanu and Ayelet are helping run. And I'm a theoretician. I work with pencil and paper and computers rather than hardware, but I think closely about quantum hardware. And I'm part of the team that invented the basic architecture for using superconducting qubits to try to build quantum computers that's been adopted by Google and IBM and Rigetti and other companies around the world and lots of academic places. And maybe one fun fact about myself, I grew up in a small village in northern New York State, and there were 5 kids in my high school class.
Thanks a lot. And then our last panelist, Kelly, do you want to introduce yourself, please?
Sure. Good morning, everyone. My name is Kelly Ratliff, and I am on the recruitment and admissions team for the College of Engineering here at the University of Arizona, which, as you heard, is one of the partner institutions for the Center for Quantum Networks. So I'm really excited to be here today. I am not a scientist or a physicist, but I help support the students who will be our future scientists and physicists. So I work with incoming first-year students and incoming transfer students and help them determine their path forward into a STEM, engineering, or maybe even a quantum career. So I'm really pleased to be a part of this excellent group, and I look forward to chatting with you all today. Thanks for having me.
Thank you. I can follow up on that, saying that there's also a lot of career, like when we think about career in quantum, we automatically think about scientists, we think about a lot of people like working on quantum science, but there's also a lot of people in the background. And one of the last events that we will have in this series will be with alternative careers for people who are supporting all the staff and all these efforts. So we'll have that probably in December. Okay, let's start these things with our first question. So I think this question will be more for our two panelists, ayelet and Shantanu. Can you tell us a little bit more, like, what's your experience in college, and like how did you find out what you wanted to do, and how did you decide to study quantum?
Yeah, sure. I'm happy to start it off. So one of the best pieces of advice I received from any professor my first year was one of my professors was talking about how kids who found success in their high school career are often really too scared to pivot to something else and try something new. I actually entered Yale as a neuroscience major. I felt very secure in that. And then during my first year, I fell in love with physics. And I felt like, should I change? Should I not? And then because of this professor's advice, I decided to go for it. And now in my second year since I started Yale, I'm falling in love with the intersection of physics and computer science, specifically quantum computing. And I guess my biggest piece of advice is to maintain an open attitude, take classes that interest you, and be willing to embrace changes in what you want to study.
Yeah, absolutely. You know, I think when I entered, or when I was first interested in quantum information science, it was because of all the potential, right? Like the potential of quantum advantage, the potential to impact, create impact across industries. That really interested me. And the reason why I actually stuck to quantum information science, I mean, it was absolutely very interesting, but it was because of the people around me, because of the communities that I was able to, take part in, because of my roommate from my second year, how we kind of worked together, work through some of these concepts. And I think because of that community, I was able to really like prosper and continue to develop my interest into now what is my passion and what I'll probably continue to do for the rest of my life. Yeah.
So since you were talking, can you say a little bit more about the Yale Quantum Computing Club that you organized?
Absolutely. Yeah, absolutely. And that you helped us launch, Florian. But yeah, last fall, we created the Yale Undergrad Quantum Computing Group. Looking back, I think there are three reasons that I started up this group. The first was to make that community, right, that I talked about. Because I was lucky enough to have a suite mate who was interested in the same thing, but having like a club, having a sort of an organization there for students who are just starting out, who are really interested and who need that sort of support network would be very useful. So that was the first thing, to build community. The second thing was because I wanted to reach people who didn't, who were interested in quantum computing, but they didn't have this sort of background in physics or computer science, right? They came from other STEM fields, they came from non-STEM fields, and they had that amazing potential to make impact, but they didn't, no one had really like told them that, this is something that you can do. So yeah, so it was a cool club where people from interdisciplinary backgrounds could come in and create impact. And the third reason was because I wanted to work on cool projects. And I wanted to work on cool projects with people from different backgrounds and different perspectives. I think that's where the coolest projects come from, when you have people that are coming from different backgrounds. Yeah, so, and I think all those three reasons were achieved and will continue to, I guess, like be met in the coming years.
Thank you. The fact that we're mixing so many people across so many disciplines is also the challenge of this technology and this field, because we are going to need a lot of people. And so there's not a single, it's great for all of you trying to consider career in quantum, but it's also a little bit difficult for us to give you one answer, because you can enter the field in so many different ways. That's something that's very challenging. And I think the US is trying to help that by launching initiative like the Center for Quantum Network for all the different hubs, national hubs of the quantum initiatives. And is it something that you can talk a little bit more about, Steve, about this center?
Yeah, so first thing to understand is that quantum computing is at a very early stage. You know, it's maybe we've invented the quantum abacus, or you know, some very crude versions of computers exist, but they're not that useful yet. And so we have many problems to solve, and it's going to take a while. So young people your age are needed to come into the field to help us solve these problems over the next 10 or 20 years, or however long it takes. And so the center that I direct, C2QA, is a very large national center. There are 24 institutions, 5 federal labs, 18 universities, and IBM as our industrial partner, because they have experience. You know, physicists are not system builders or even computer scientists. And so, you know, people with industrial experience are, of course, valuable. And what's called the technology readiness level is just very low. There are many, many problems to solve, and you can contribute whether you're a mechanical engineer, electrical engineer, a computer scientist, a physicist, a material scientist, a chemist. We're trying to invent an entirely new type of technology. And no one person or even no group of people all from the same background could possibly solve all the engineering challenges that we face. So that again means there are many routes for you to enter this field, and it means that centers like the one that I direct are important precisely because they bring together people who haven't been talking to each other before. So I'm now collaborating with computer scientists that I know very little about computer science. I know a little bit about physics and a little bit about quantum computing. And we're working together to try to think about how do you write programs for quantum computers? How do you compile them? How do you get them to work even though the hardware is still not very reliable? There are people that are work with high-speed electronics. There are people that just come from all kinds of backgrounds. And so it's really an opportunity to build communities with diverse backgrounds to try to tackle these big challenges.
Well, speaking of that, like, how do you, you have all these avenues to enter this field, but like, how do you decide which one is good for you? Can one of you panelists tell me, like, if you had, like, what kind of experience you had to sort of like try different things? Like, is there tools online that you can use? Like, what kind of activities you can do? I'm hinting at maybe a hackathon just some just some hints. Does one of you want to talk about that?
Yeah, I can say a bit about expand on that hint. Yeah, we had this fantastic event, the Quantum Coalition Hack, that ayelet have helped lead, and this was really incredible event because we had sponsorship from companies across the world. So our biggest sponsors were IBM and Q Control and Google, and we had a ton of other sponsors. And I think the coolest thing though was that we had 2,000 people sign up. 1,400 people participate in some way, and 200 teams of like 3 to 5 people submit projects. And this shows how much interest there is out there. And this hackathon was conducted completely virtually, right? So without needing to go into a lab, without needing to even have a very strong laptop, we had sponsors that would provide online interfaces that you could use if you didn't have very powerful computing tools at home. So I think this is a testament to how many resources now exist on the cloud that are free to use. I also am an IBM Qiskit advocate. So I've had some experience with Qiskit, with contributing to Qiskit, which is open source, and I can say for at least for Qiskit, there are a ton of tutorials. There's a wonderful online interface with IBM Quantum Experience, and there's a really vibrant community out there. So there's like a popping Slack channel where you can just ask, if you're coming in if you're an industry professional, if you're a college student, if you're a high school student, you can just go there and get some help and get started. And this is one of the many tools out there. So definitely, if you're interested, I would say there are tools out there to support you. There are communities out there to support you. And the best way to get started is to, go through one of these intro tutorials if you're interested in quantum information science.
So the one
I just want to add.
Go ahead.
Thank you so much. I just want to add one more note on the hackathon. So I had just joined UQC as Director of Partnerships, but as I mentioned, I'd literally had my first quantum computing lecture a month before. And then it was my responsibility to reach out to all of these sponsors and ask them to join our hackathon. And it felt like a pretty big request, and I was very nervous being a beginner to the field. But I was amazed by how dedicated these sponsors were to bringing in the next generation and specifically to bringing in new perspectives. I think that's kind of what's special about the quantum computing community, is that people really understand the need for interdisciplinary collaboration, and they're really open to bringing in beginners. That's just been really reassuring and exciting for me as a beginner to this field.
So all the resources online. Like, I think if you just do a quick search on Google about these different things, you will be able to find them. A few things that we can point out is that so IBM has a lot of resources. Qiskit has a lot of also resources and tutorial. Google has also a series of videos online. Microsoft is starting to ramp up their programming, so they have more and more things. And one thing that I can point out, if you give me a second so I can change my slide, there's this school, so you can see on my webcam, the qubitbyqubit.org is a website that has a ton of resources. And they are currently hosting summer camp for middle school, high school, and college students. And we have also a quantum, they also have a quantum summer school for researchers. So there's a lot of things available. And one of the advice that I will give you, if you're interested in the fields, but you don't know exactly what to do, it's really to try to follow tutorials. There's like some very short exercise and some it's almost the shape of a homework, and you can starting with a compiler and try to test your very first code on the quantum computers. And so to follow on that, Steve, could you tell us a little bit more, because I know that you use the IBM experience for your classes. Can you tell a little bit more about the interaction of the students with these quantum computers?
Sure. So I'm presently teaching an undergraduate course at Yale, Physics 345. And you don't have to have any background in physics to take it. The only prerequisite is to know a little bit about linear algebra, solving sets of simultaneous equations, basically. And so I give, some lectures on the background, and then when students have a little background, they can start programming and doing homework assignments on the IBM quantum experience. Florian is putting up the one of the interfaces that you can use, and it's very simple drag and drop graphical interface to start. You don't even have to write code, you just drop different quantum gates or operations into a circuit. And there's a lot of online tutorials with IBM Q and with Qiskit to show you how to use this. And it's a lot of fun. Students really enjoy playing this. It's completely free. You can have access. As a professor, I'm a member of the education network at IBM, and so we have a little extra access to the machines, but anybody anywhere in the world is welcome to log in and start playing with these at no charge. So if you're curious to learn a little bit about, try your hand at some simple, very simple programs, then you can just go ahead and start today.
We have a question in the Q&A panel for you, Shantanu. So Isaac said that he imagines that creating an undergrad club on such a complex and advanced subject is not pretty easy. He would be interested in knowing how you prepared and study in order to empower enough people to propose the creation of this club.
Yeah, it's a good question, and something that I grappled with when I was going to start this, when I was thinking of starting this organization, because Yale has a really rich history in quantum information science and quantum engineering, and here I thought, is it okay for me to create a club like this? And I think what motivated me was we had an interest meeting, and there were a lot of undergraduates that were interested in such a club, right? They came. We actually, I like to look at the numbers, and we had, I think we had like 10 or 15 different majors outside of physics and computer science and math that were interested in joining such a club, right? That wouldn't have had access to these amazing resources, this rich history and graduate community at Yale, if not for a club like this. So that's why I continued with it. That's how I got the motivation. And as for how I got the resources to support this, I found that a lot of the resources were already kind of there, and I just had to reach out to ask. So I asked Professor Gervin, and he was really helpful. And I asked Florian, he was very, very helpful. And I think the best thing that I could have done, and I did, was gather a really talented board of people, right, who are like ayelet, who are really enthusiastic about such a venture. So I should note, that's more of a motivation and a little bit of advice. Surround yourself by people who are interested and passionate if you're trying to start a club like this. And on a more practical note, this quantum coalition hack that we mentioned before is not going to be contained to the quantum coalition hack. It's actually kind of like a cool network of universities across the world. So if you're at a university and you need some support in starting a club, you can just join our Discord. Go to our site, quantumcoalition.io, and we're also going to host a webinar where we kind of talk about how to create a club. And this is, I know there are a ton of resources out there, and so we're going to try to work with everyone so that we're not so that we're taking full advantage of all the synergies. So the main point there is that there are people who are interested in such a thing, and there are a lot of people who are interested in working with you to create cool clubs like quantum computing clubs.
And I can add to this that there was an opinion piece written, I think, 6 months ago, and then the main concern and the main limiting factor of quantum science will be the workforce, because we're at the point where we don't have enough people trained on all of this field. And so the reason why it's so important these days, and why everybody from the tech giants to the university to the high school teachers are like really trying to bring together the workforce, is because that's going to be the limiting factor. And so I think you can use that to your advantage and like reach out to people and say like, oh, I'm a high school student, I'm interested in doing that. Can you help me do that? And like, I'm pretty sure you will have all your answer, like, yes, please, here, like, we can help you with this thing. These are some resources here, like, you can read onto that. And so that's really something that's going to be, so the field is it's challenging because it's a new field, and so it's going to be a lot of work for everybody, but there's also, we are in the really good shape right now. This is the perfect time to join this field because that's going to be the time where everybody wants you, and somebody with a quantum background will be really looked for on the job market after that. And so since this session is to prepare for college, and or like if you're like on your first year of college, maybe we can ask Kelly, like, what are the advice that you can give as a recruiter to like how can you put your best chances to enter a college and then study this field?
Sure. So I can kind of speak from the perspective of our engineering program at the University of Arizona. And it's good to keep in mind that every institution is going to be different in terms of their process and the programs they offer. But as we mentioned, you know, the cool thing about this field is that you can come at it from a variety of different backgrounds. So I loved ayelet's advice about having an open mind. And I think that is super important as you're going through your college search process, as you're thinking about what you want to major in. And it is okay as a high school student to not know today or when you're applying what exactly you want to do for the next 4 years. So that's one of my biggest pieces of advice too, is to just be curious, have an open mind, and pursue the things that you really enjoy. So the way our program at the University of Arizona is set up in our engineering school is actually all of our engineering students come into the college. They don't choose a major right away. So we have a built-in first semester course where you actually meet all now 16. We just added a major in software engineering that was announced this week. So we have 16 programs now that you get to pick from. So if you have a career path in mind, you may find a variety of majors that really speak to what your future goal is. So if your future goal is in quantum, you may want to pursue physics instead of engineering. You may want to pursue software engineering or material science. I know our department head here in material science at the University of Arizona, he's also working on a quantum computing project using sound. So there's a lot of different ways that you can add on to your college experience outside of your major. So these research opportunities, internships, those are all things that can supplement you as you're going through. So it's okay to not know right now exactly what the next 4 years are going to look like. Just keep an open mind. And I would say, as you know, my advice as an admissions person is if you're interested in a career in any one of the science fields or engineering or math in high school, pursue as many of those courses as you can, as much math, especially calculus-based math for engineering. That's super important for us. Math and science in high school, take whatever you can, get involved in clubs, whatever they may be, whether it's coding or robotics or whatever interests you. And you're going to have a great foundation coming in, having taken those courses. And it's really going to set you up for success, you know, transitioning into college level physics, chemistry, calculus, all of those things coming in your first year. So there's lots of ways to slice it, but I would say the more that you can pursue those foundations in high school, the more prepared and confident you'll feel coming into a university setting where you're using all of those skills and building upon them.
Thank you. We're going to take a question from Jamie in the Q&A panel. He said that he recently completed the IBM QXQ coding school, and there's like a lot of online school that you can take. And most of the positions I've seen are for PhDs or engineers. And so I think that's the case for now. A lot of people, since we're at the very beginning of the field, it's much easier for a research center to develop this kind of work. But I think it's going to expand to different kind of position. But can one of you in the panel tell us, like, what do you think the workforce will be in the short term and in the long term? Like, will it be a shift between like only PhDs, or is it going to be the turn of like more engineers, more masters? What kind of diploma should you get for now? I know it's a bit of a tough question because we don't know what the field's going to look like, but if one of you can try to hint at that, that would be great.
I mean, I could actually maybe chime in a little bit about this. So just kind of based on some of the research that's out there, just because things are, and some of this is my opinion too, but just kind of early on, since a lot of this is still being figured out and developed, that there's kind of a need for PhDs and kind of scientists to kind of lay that groundwork. And then later on for master's students and so on to kind of then come in and execute these things. So that's kind of my thought.
Yeah, I could add a little bit. I mean, right now, quantum computers are hand assembled mostly by PhDs, mostly physicists, some engineers, but the field is evolving so rapidly, and there's no way that we can expect somebody to become an electrical engineer and then take another 6 years and get a PhD also in quantum physics. We have to find ways for people to start contributing, give them easy ways to learn enough about the basics of quantum so they can bring their expertise from whatever field they're in to bear on the numerous problems that we're trying to solve. So this is actually a big question in industry and for the federal government right now. How do we learn how to do that? I'm part of a panel that was at an NSF, National Science Foundation workshop, to try to figure out just how do you create courses for undergrads to get them introduced to quantum, and what should the requirements be, and what should you teach, and what should you teach for the beginners and the more advanced students. And it's such a new field, we're still figuring this out. And going back to the things that Kelly was saying earlier, what is the best? You can contribute, you can get into this field from almost any field. And what you should pick to work on in college is just whatever you're excited about. It doesn't matter. When you go, you can use that as some expertise in that area, plus a little study or one course or personal effort to learn a little bit about quantum to get yourself an entree. It really doesn't matter. It's more important to be passionate about something and use that passion to learn than to say, oh, I want to get into quantum and I should study this, even though it's not the thing I'm most excited about. That's a mistake. And you're gonna major in something in college. You may change your mind what your major is. That's what college is for. It's the one time in your life when you can explore and try out things. And after college, you might decide to go to graduate school and get a master's degree, and it might be in a different field. You might move from electrical engineering to physics or vice versa. That's not uncommon. And so don't try to think there's some absolutely single best route to take. There are many ways in, and you should take the one with the most interesting scenery along the route.
That's a very good point. To talk about personal experience, when I was never really like in high school, I really hated school. I didn't really want to continue. So I went to a vocational school for 2 years, and then slowly I was like, well, you've done enough work, and then maybe you can do an engineering school in the back, and then I went to a grad school, and then I went to a postdoc, and then you end up in this position. And so really, like if you have a plan, that's great, but also there's a ton of opportunities everywhere. And so if you limit yourself to one thing, you might miss out on really fascinating opportunities that you might have. Yeah, college is a really good time for that, to try to figure out what to do and what you like and what you don't like, because sometimes it's also very much easier to figure out what you don't like. You take one class of intro of, I don't know, something about, I don't want to like pinpoint on the matter because somebody's going to be mad since we have so many field represented here. But yeah, you will quickly realize if you like the subject or not, and then you can decide what to do.
Yeah, maybe I can add a quick note from the perspective of someone who was looking at some of these job opportunities, both to collect them for our club and also just because I was a bit interested. Because I'm working currently, and I'm working for a bit before I go to grad school. I'm working as a software engineer, and that's my first point. So the skills that you develop when working in quantum information science, working on these projects, are very transferable. And that goes both ways, right? Like you can come in from any background, you can also pursue a lot of different things afterwards. So it's a very worthwhile effort. And when going to college, one of the pieces of advice that I give is, do what you want to do. And also, if you're interested in something, don't be afraid of like really diving deep and getting your hands dirty. That will be time well spent. So another thing I want to note is I looked at these job postings and I've seen some really cool roles pop up. So at companies like Amazon and Google, I see software developer roles pop up that don't require a PhD background. So this is kind of like to the point of building the infrastructure, right? Necessary to achieve, something like quantum advantage at a large scale. You don't just need physics PhDs. You also need software engineers and a lot of other people like throughout the stack, right? So to speak of quantum computing. So there are a lot of transferable skills, and there are opportunities that are already popping up and will continue to pop up.
Maybe that's a good time to present the upcoming events that we have in this series. Give me 1 second. Here we go. Because since there's so many careers, we have a series of events. So the next one will be for preparing for grad school, because of course, as somebody mentioned, PhD are very important right now. But then we have some more panels to cover like most of the different positions you can get. So grad school will be in June. In August, we will have for faculty members, for young postdocs who wants to go in academia and try to get tenure in a university. In October, we'll have a panel on startups. So all the work that has been done by the startups, and most of the quantum computer, the big player in the role, started from startups from university. So I think we're at the phase where the startup are transitioning into these big tech giants. So that's going to be an exciting time. And then in December, we'll have for industry jobs and what you can do to make yourself more valuable in the field. And I think that will be one that will be very interesting. Like we had a couple of questions about that in the chat. We are almost running out of time. Maybe we can look back to each of you, and you can tell us, like, in a minute or so, like what, like your hot take on how we could prepare for college, and like what's the advice you can give our audience. Maybe I should start. Who wants to start? Let's. I'm gonna pinpoint on that. Ayelet, do you want to start? The last word on that?
Yeah, sure. I do want to reiterate what I said before and what Kelly echoed about maintaining an open attitude. And I also want to emphasize that you can find a way to contribute to quantum if you have a desire to learn. It is often an intimidating field, but if you have that desire to learn, no matter how beginner you are, you can find a way to contribute.
Shantanu?
Yeah, absolutely. So on a, I guess, more general advice note, try to find someone with whom you can actually learn this material. That's really helpful to have someone there to motivate you. And on a more practical note, if you're interested in like quantum information science in particular and actually running these circuits, I would say the only requisite would be learning a bit about how matrices work with each other. So like how they add and how they multiply vectors. And I think that's like from a practical standpoint. And in terms of opportunities, you don't have to wait for an internship. You don't have to wait for like some opportunity to come up in terms of like a formal program. You can start contributing to open source projects. If you're, for example, if you're interested in computer science, you can find the Qiskit, the Qiskit GitHubs and repos, and you can start contributing right away. So yeah, don't be afraid to get started. Find someone to help motivate you and to bounce off ideas with. And if you're interested, try to learn a bit about linear algebra. I think that'll be really helpful.
Russell?
So I think I'll echo kind of some of the stuff that's come up here. Is find a major, find a field that you're interested in. Do some research about the different pathways. We've talked about some of them today, but I think find something that you really enjoy and that you can be passionate about, and you'll find a way into the quantum workforce. And just keep an eye out for different opportunities to get involved with outreach or some of the extracurriculars that we've talked about. I think that's going to be really important, because that's more of a informal kind of laid back way to kind of test, if you're going to enjoy this, and making connections with people too at those events.
Kelly?
Sure, I guess one maybe kind of different thing that we haven't discussed that's on my mind this week is May 1st, as you may have heard, is traditional kind of National College Decision Day. So I've been talking to a lot of high school students and parents this week who are just really worried. They don't want to make the wrong decision, and in their words. And so I would just say, don't worry a lot about something like that. There are so many wonderful programs in the US and around the world related to these fields. And really, it's just about finding a place that you feel like is a place you want to spend the next 4 years, that feels comfortable to you, that feels welcoming to you. And so don't worry so much about picking the wrong school or the wrong program or the wrong major. You'll find your path as you go through college, and really it's about finding a place that feels like home to you. So if you're able to do campus visits when you're doing your college search, or talking to other students. I know one of the things I do a lot in my job is connect high school students to current undergrads to talk about things like research or their experience or internships or whatever it may be. So just have an open mind, apply to any place that interests you, and then if you can, try to visit and focus on picking a place that feels like you, and you'll be successful.
Thank you. Steve, last word?
Yeah, so, just as it's easier to learn languages when you're young, I think it's easier to learn mathematics when you're young. And so as Shantanu mentioned, really the minimum mathematics you need to know about to enter this field is linear algebra, how to solve simultaneous equations, how to work with matrices and vectors. And there are wonderful websites like 3 Blue 1 Brown, where you can see amazingly wonderful videos that teach you these things. And you can start there. You can take a course when you get to college. And I would learn that first. I would, probability and statistics turns out to also be an important part of quantum, because there's a certain randomness in the way quantum mechanics works. And that's a very, very important area anyway in modern data-driven society. And so that'll be a skill, even if you end up not going into quantum or not even going into science, it'll make you a better citizen. You can understand, the statistics that people are using to argue for different policies. So I would, if you had to pick one thing to suggest you study, it's discrete mathematics.
All right. So we're going to conclude on this thing. Thank you all to the panel. Thank you all for attending, and thank you also for your time, for all the panelists who are here. I hope you learned a lot about what we're doing. We have posted in the chat a lot of links. So we had some of the videos that we're talking about, 3 Blue 1 Brown, some of the websites that you can find more with the resources, and then otherwise Google is really helpful. If you do a quick search, you should find a ton of things, and don't forget to ask people. So that would be great. Thank you all, and we hope to see you next time. So yeah, our next event will be, if I pick the date, will be on June 18 at 2 p.m. Pacific time and 5 p.m. Eastern time. So if you're interested in that, please let us know. In your registration, you had a place to receive email for the upcoming event, so we will send that. We will send that shortly. Thank you all, and have a great rest of your morning, rest of your afternoon, or everywhere you are in the world. Thank you. Bye.
Bye.